back to another lesson. Today's learning goal is I can use properties of exponents to simplify and evaluate power expressions. Today we're going to be learning about the power of a power property. Okay, and so again we're going to be dealing with powers, but we're going to be dealing when we have a power to a power. So for example, 5 to the third in parentheses to the second power. Now this has two exponents. We're going to first deal with the second exponent out here. Now, what this second exponent means is that anything that's inside this parentheses is going to be doubled. So that means we have 5 to the third times 5 to the third right here. Okay. Now, 5 to the third means 5 multiplied 3 times. So that's 5 times 5 times 5 times another 5 times 5 times 5. So as repeated multiplication, we have 6 5s overall. That means we have 6 factors. And this means that this is 5 to the 6th. Okay. Here, this is negative 6 to the second power to the 4th power. Now, what we have here is negative 6 to the second 4 times. So we have negative 6 to the second 4 times. And then we have negative 6 times 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 negative 6, which means we have, ooh, that's not right. There's 2 more of those because that's to the 8th. It should be to the 8th because there's 4 of these and twice for each one. So there should be 8 of those. Let me fix that. Negative 6, negative 6. So there's 8 of them, which means there are a total of 8 factors, not 6 factors. This should, oh, it does say 8. 8 factors right here. And that means this is negative 6 to the 8th. However, remember that since there are, we're multiplying 8 negative numbers, so remember that every negative number times another negative number is a positive number. Okay, so therefore, this is not actually negative 6 to the 8th, because we can simplify that even further to 6 to the 8th, because we know our final answer is going to be a positive number because we have an even number of factors. Okay, so whenever you have a negative number that's being taken to an even power, we can write that in a simplified version as the positive version of that. So that's a special case right there. A to the third, so that's a to the third times a to the third times a to the third, and now we have 9 a's right here, which means there are 9 factors, a to the 9th. Okay, so it says find a pattern that relates the exponents of the expression in the first column and the exponents in the expression of this last column, and explain how you can use your pattern for another question like this. Okay, so go ahead and try that out on your own. Here, we should have found that the exponent in the simplified expression is the product of the 2 exponents in the original expression. So for example, b to the second to the 5th is b to the 10th, because 2 times 5 is 10. So, to find the power of a power, okay, what we can do is multiply the exponents. So here we got 3 to the 4th to the second is 3 to the 4 times 2, which is 3 to the 8th. Or here, a to the m to the n is the same thing as a to the m times n. So again, the long way is 5 to the second times 5 to the second times, or excuse me, 5 times 5 times 5 times 5 times 5 times 5. That's repeated multiplication for here, because this is 6 of them. The shortcut way is 5 to the 2 times 3, which gives us 5 to the 6, because there are 6 factors here. Go ahead and try this one out on your own. Yes, there are a lot of n's here, and I apologize, but there should be 14 n's here, which is n to the 7 times 2, which is n to the 14th. So go ahead and try these out on your own. P to the 3 times to the 4 is p to the 12th, because 3 times 4 is 12. Here we have 3/4 to the 15th, because 5 times 3 is 15. Here we have 2 and 3, so we get the base of 2a to the 6th, but because we have variables and numbers in here, we want to simplify this further to 64a to the 6th, because 2 to the 6th is 64. So here what we have is 3x to the third to the second. Okay. So if we try to write that out, this second has to be applied to both the number and this x to the third. So this is going to be 3 to the second, 3 to the second, and x to the sixth. Now we can simplify that further because there's variables and numbers, so that's going to be 9x to the sixth. Here there's no variables, so we're just going to do 6 times 4, which is 24, so we get 2/7, which should be 24. That should say 24. Okay, to the 24th. Here, this becomes 2 times 3, which is 2a to the 6, because 2 times 3 is 6. Then we're going to take this to the 2 to the 6th, which, as we know, is 64, and a to the 6th. I believe that's the exact same question as the previous one. That is. Oops. All right. And here, negative x to the 4th to the 3rd. This is going to be negative x to the 12th. But remember that this is a negative number, and this is taken to an even exponent. And we know that negatives cancel each other out when we have an even exponent. So our final answer is x to the 12th. This is that special case that we were talking about earlier. Okay. Then we have this down here. Go ahead and try these out on your own. Here we have 5 to the 3rd to the 4th, which is 5 to the 12th. This should be 2.3 to the 8th. Here we have 16 p to the 4th, because we turn this into 2p, or excuse me, 4, or 2p to the 4th. Let me fix that up. 2p to the 4th, in parentheses, to the 4th, and then 2 to the 4th is 16, and p to the 4th is obviously p to the 4th. Here, this should be p to the 20th. Again, this is that special case because this should have been negative p to the 20th, with the negative in the parentheses, which we know is going to be the positive form of that because it's an even exponent. Here we're going to have to apply multiple of these properties at the same time. We're going to always do the properties that we can do inside the brackets first if there's brackets, and then inside the parentheses if we can. So here we have negative 4 to the 2nd times negative 4 to the 3rd. That should get us negative 4 to the 5th using the product rule. Then we have 5 to the 6th, which is negative 4 to the 30th. And because we know that this is going to be an even number, or an even exponent with a negative base, we know this is 4 to the 30th. Okay. Here, m to the 5th times m is m to the 6th, so we get m to the 6th to the 3rd, which is m to the 18th. Here again, we're going to simplify both the numerator and the denominator and then do the quotient rule. So here we get 6 to the 4th times 6 to the 3rd up here, so that's 6 to the 7th to the 4th at the top, and then 6 to the 2nd to the 5th. Multiply 2 and 5, we get 10. Then we still need to simplify the top. 7 and 4 gets us 28 by the power rule, and then we subtract using the quotient rule, we get 6 to the 18th. And then finally here, a to the 4th times a to the 2nd is going to be a to the 6th. And then here, we just have 2a to the 8th. We still need to simplify the top, gets us a to the 24th, and then we subtract using the power rule. 24 minus 8 is 16, so we have a to the 16th. There's no a's left over here because we crossed them all out, leaving us with 2 at the bottom. These are the problems that we're going to do at the beginning of class the next day. Notice here that we have 2a to the 2nd, b to the 4th, all of it to the 3rd power. Think about what you might do with this one.